Hi everyone, this video is going to be our lecture for today. I'm going to go over how to write your formal lab report and what to include in each section. 2 weeks ago I went over how to write the formal lab report in general. So if you can, please print out that file or put it on a side and have today's lecture on the other side for each section when you're writing your formal lab report. That way you don't miss anything. So you will start off with writing an introduction first. So how you would do this is you would look up history on saponification for this lab. When you look up some stuff, make sure while you're writing your introduction, you start creating your works cited page. So then I would search up, who discovered saponification, when, how, and why is it also called Ester hydrolysis. So you need to answer these questions in your introduction. Then go into discussing the mechanism of saponification stepwise, but this is going to be your general mechanism. So it's not what we're doing in the lab. So it's general mechanism of saponification. And then briefly introduce nucleophilic addition and elimination, and then discuss the acid-base reaction. After that, you can go into answering question 2A in the pre-lab. Sorry about the bird. And then discuss briefly what reflux is, chromatography, and extraction, and how you can use them in the lab. Okay, I'm sure you heard I have a canary in the house. Anyway, I'm sorry about that. Then discuss the propanoic acid and how do you create it? What is it commonly used for? So you need to search up all these. At the end of your introduction, you're going to end with an objective of this experiment. So something like, prepare propanoic acid by ester hydrolysis or saponification, purified by extraction, and analyze the product by IR and NMR. What I didn't mention here is when you briefly discuss reflux chromatography. In chromatography, that's where you're gonna also include your IR and NMR stuff. So make sure you use at least 4 references. A lot of times students use, I don't know, like maybe 7, 8. But 4 is the minimum I ask for. So, like I mentioned, as you're writing the introduction, make sure you create your works cited page. Make sure the numbering in your introduction is matching with your reference. Don't mess up on the numbers. I will be checking your references. Next, you will create your experimental section. So you're going to put a picture of your propanoic acid, and then in bold letters, you're going to write propanoic acid. And then beneath that, it will be a paragraph of your procedure. There is an example of this in my other notes, so please refer to that on how to write your procedure section. Then you will go into the results section. So in results, we're going to put everything we obtained in the experiment. So first you would put the reaction of the mechanism of this experiment using the curved arrow formalism. You will title that as a figure. So that will be your figure 1. Beneath that, you will briefly discuss, what figure 1 is. Then you would include your post-lab questions 2, 3, and then there's another question 3, A, B, C, D, E. When in this post-lab questions, you have tables to create. When you're creating the table, make sure this bird doesn't stop. make sure that your table is labeled correctly. If you can refer to my, excuse me a minute. If you can refer to my other packet, it'll show you how to label your tables. Make sure you're labeling everything in chronological order. Then put your results of your FTIR, your NMR, and your TLC plates. When you're putting your TLC plates, you obviously going to have multiple TLC plates in your experiment. So the best way to express these is to make a bigger image. So like, I don't know, use your Paint app and copy and paste your 3 TLC plates right next to one another, right? So you have start, mid, and end. So you should have 3 different expressions of the TLC plates, and then you can label this as figure, I don't know, whatever number you're on. So like figure, so figure goes on the bottom, so figure, let's say 3, and then explain what figure 3 is, and what is after you explain what the figure 3 is, you need to explain to me, you know, on TLC plate A, that is our starting, and we have this material present. On TLC plate B, shown in figure 3, we have, you know, this product present, and then this reactant missing, or whatever, or is still showing. And then on TLC plate, you know, C, we can see that all the products have been present and there's no more reactants. Blah, 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 blah. You guys can word that in your own words. Then it says, okay, so you refer to your old packet of how to label the figures and tables. Now, right here, what I have is our question 3, the second 3 that has A, B, C, D, E present. So I'm going to go over step by step how to do this, just because Beyond Labs obviously is not giving you any values, and then the values that I forwarded to you from the department kind of have a weird result. So I did the math, and it was just didn't make sense, and I don't want you doing the math and ending up with values that you have no idea how to explain that in your discussion section. So for part A, it says calculate the moles of propanoic acid that methylpropionate would form if it were the limiting reactant using 1.30 milliliters of methylpropanoate. So first, what we have to do is we need to convert the 1.30 methylpropanoate milliliters into grams, and how we do that is we multiply it by the density. So we have 1.30 milliliters of methylpropionate, which is C4H8O2. And so this is given, then we multiply it by the density, that's 0.915 grams of H8O2 divided by milliliters of C4H8O2. You need to label all your units, and you need to show me how things cancel out. So then we multiply that by the molecular weight of methylpropionate. So that is, we have 1 mole of C4, H8O2 divided by 88.11 grams of C4H8O2. Then we will multiply these by the moles. If you look up the chemical equation, it is already balanced for us. So we have 1-to-1 ratio. So we are creating 1 mole of propanoic acid, which is C3H6O2, by using 1 mole of methylpropionate, which is C4H8O2. So when you do the math here, you see that the milliliters cancel out, the grams cancel out, the moles cancel out, and we're left with whatever the question is asking us. Calculate moles of propanoic acid. That's what we are left with here. So if you do the math, you are left with 0.0, this is not writing good, 0.0135 moles of C3H6O2. Okay, so next question asks us to calculate the moles of propanoic acid that KOH would form if it were the limiting reactant. Now I changed this, so this is changed. Now this used to be 0.034 grams. I changed it to 0.034 grams. So that math, now we don't have to convert milliliters to grams, so it's already in grams, so we use that. So we have 0.34 grams of KOH multiplied by the molecular weight of KOH, which is 1 mole KOH divided by 56.106 grams of KOH. And then we will multiply that by the moles. It's again 1-to-1 ratio. So we have 1 mole of propanoic acid, which is C3H6O2, created by using 1 mole of KOH. So things will cancel out again. Grams of KOH cancel out. Moles of KOH cancel out. We're left with moles of propanoic acid, right? And that's our moles of propanoic acid. So if you do the math, or if you just copy my answers, you will get 0.006 moles of C3H6O2. Now next question asks us what compound, methylpropionate or KOH, is the limiting reactant, and explain why. Your limiting reactant is the least value, and that is which one is the least? So we see that the KOH. So KOH, because it creates less of propanoic acid. Now it says calculate the theoretical yield. How we do that is we take the limiting reactant, so the least amount, which was 0.006 moles of C3H6O2. We multiply that by the molecular weight of propanoic acid. So we need to get everything in propanoic acid in grams. So we have to get that as our final answer. So we multiply that by the molecular weight of propanoic acid, which is 74.08 grams of C3H6O2 divided by 1 mole of C3H6O2. As you can see here, the moles cancel out, so we're left with grams of propanoic acid, and the answer is going to be 0.4 in the correct significant figures, more grams of C3H6O3. So now it says here, if the actual amount obtained of propanoic acid 0.84. If you do this math, it's gonna give you 200% yield. And how are you gonna explain that to me? I think you're gonna have a hard time explaining that to me. So if you do this math and you end up with 200%, that means that your product is probably still wet, or something didn't go right. You have some kind of contamination. So what I did was I changed this 84 to 25. So if you do the math now, it should make more sense. So how we do the percent yield is that percent yield is actual over theoretical, and that will be, the actual is given to us 0.25 divided by 0.4, and you multiply by 100 to get percent, and you will get 63% correct significant figures. So you need to show me all that math. I did it for you guys, but I hope you follow along and understand how to do that, because on the final exam, obviously I'm not going to do the exam for you. Next we will go into our discussion section. So we have to relate the results to the theory that is mentioned in the introduction. We'll outline the actual reactions that took place. So in the introduction, remember, it was just the general overall mechanism. So here we're doing the actual mechanism, and we'll do the curved arrow formalism. And then you need to answer the post-lab questions 4, 5A, 5B, and 6. And once you're done answering question 6, you can discuss if the objective of this experiment was met. Was the experiment successful or not? And why or why not? Explain to me if it was successful. If it wasn't successful, explain to me why it wasn't successful. And then finally, please discuss any sources of error. Also, side note here, anytime you relate to an image or a table, make sure that you're stating it as you're discussing it. So say, like, as shown in figure 1, and you discuss figure 1, or as shown in table 2, you discuss table 2. Do not have any pictures, any figures, any tables that you do not discuss in your discussion section. If you are not referring to any image, then you need to exclude that image. You cannot keep it in your report. You will have points off taken if you have an image that you don't discuss, or a table. So you need to make sure everything in your results section is discussed in the discussion section, and it's referred to it, like, shown in figure 1, shown in table 1, shown in table 2. So you need to make sure everything is lined up. Once you're done with your discussion, which is going to be a long part, you will write a brief conclusion. In conclusion, everything is going to be repeated again here. So you'll summarize briefly the results and discussion sections in like a paragraph or two. I think it's 2 paragraphs. And then lastly, to conclude your conclusion, please tell me how can you improve this experiment and what would you change? Once you're done writing your conclusion, then please, after you write all this, then write your abstract. In the abstracts, you have to summarize briefly introduction, mechanism, and results, and write a brief conclusion. Make sure to place the abstract before the introduction section. It needs to be the first thing I read. Then before the introduction, before the abstract, make sure you create your cover page. You need to give me a title of this experiment in your own words. You cannot take the title from your packet. You cannot take a title from my works. Then you have to put your name and the date. Also, remember to add heading and page number to all other pages. So your cover page will not have a page number. Every other page after that will have page number. So your first page number labeling will be page number 2. Once you're done with that, you are done with your formal lab report. Please, once you are done, if I were you, I would print this packet and I would read it. Not the same day, the next day. Make sure you just read through the whole thing. Look for any grammar errors. If you have any grammar errors, those will be points taken off. You don't want to lose points for unnecessary reasons. So please read the whole thing over. Make sure your introduction references are matching with your works cited references. Everything needs to be in ACS format. If you're having a hard time with that, please email me and I can get you a file of how to format in ACS. It's also available online if you can just Google it. Lastly, please, I beg you, do not leave this to the last minute. You will not be able to pull it off. It's a lot. You have to write a lot. You have to research a lot. You're going to go back and forth a lot to make sure you covered everything. You got everything. So that's it. If you have any questions, please email me and I will get back to you as soon as I can. I hope this video was helpful and I hope you took the time to watch it. If not, it's something I did extra, so I don't know. I really hope you guys watch this video. Alright guys, next week, so you have, okay, so I'll know if you watch this video because next week we will not be having class because you have lab 9 to do and everything's already uploaded for you, so I have nothing to discuss about lab 9. So see you in 2 weeks.